Alright, this lesson is about solving rational equations such as these. First thing we should do is factor. So here we have negative 1 over x minus 3 is equal to x minus 4 over, actually that doesn't factor. Alright, that doesn't factor. So, never mind about the factoring part. The excluded values, let's get that out of the way right now, are going to come from here and here. So if I set this equal to 0 and solve, I get that x cannot equal 3. Now, if I set this equal to 0 and solve, that's going to give me x squared, cannot equal to 0 rather. X squared cannot equal 27. Then we would take the square root of both sides, and that's going to give us that x cannot equal plus or minus, and this is going to be 3 radical 3. The square root of 27 is 3 radical 3. Alright, so those are the restrictions. Now let's get down to business. Because this is just a fraction equal to a fraction, we can do this by simply cross multiplying. Okay, so if we do that, we're going to have these multiplied together, and we're going to have these multiplied together. So negative 1 times x squared minus 27 is going to give us negative, well, you know what, let me just set it up first. So we're doing negative 1 times x squared minus 27, okay, on the one hand, and we're setting that equal to, and then we're doing x minus 3 times x minus 4. Okay, over here we're going to double distribute. Okay, so x times x is x squared. X times negative 4, that's negative 4x. Negative 3 times x is negative 3x, and negative 3 times negative 4 is positive 12. Okay, combining these like terms here in the middle is going to give us x squared minus 7x plus 12. And then distributing the negative 1 here is going to give us negative x squared plus 27. Okay, so now we're just going to combine like terms. I like my x squared to be positive, so I'm going to add x squared to both sides. Okay, move it over here. And I'm going to subtract 27 from both sides. Alright, as soon as I saw that I have two different kinds of x, I have x squared and x, I know I need to get 0 on one side, so that's what I'm doing. So that's going to give me 0 is equal to 2x squared minus 7x minus 15. 12 minus 27 is negative 15. So I have this. Perhaps this is factorable, so let's give that a shot. So we will try to factor this as a binomial times a binomial. 2x squared is 2x times x. Alright, 15 is 3 times 5, or 1 times 15. So I'll try it like this. If this doesn't work, I'll try putting the 5 here and the 3 here. The key thing to remember, of course, is that inner plus outer must equal middle. Inner, I have 3x. Outer, 10x. I'm trying to get a middle of negative 7. I can get negative 7 if I have a positive 3 and a negative 10. That will make negative 7x. So there's my positive 3, and a negative 5 will make negative 10. Alright, then I have to make sure that I'm getting negative 15. Positive times a negative is a negative, so we have factored correctly. So to find the actual solutions, we need to set these factors equal to 0. So I'm talking about 2x plus 3 equals 0 and x minus 5 equals 0. Subtracting 3 from both sides, adding 5 to both sides, is going to give me 2x equals negative 3 and x equals 5. Okay, that's one of my solutions right there. Over here I'm going to divide both sides by 2. So dividing by 2 on both sides, that's going to give me x is equal to negative 3 over 2. So as long as these are not excluded values, these will be the solutions. Let's see, can't be 3, can't be plus or minus 3, radical 3. These are both valid, so these are the solutions. Okay. All right, taking a quick look at problem number 2. This one we cannot cross multiply because we don't just have a fraction equal to a fraction. We have this extra negative 6 in here. So you have to multiply by whatever factors you have in the denominator. I see x minus 1 in the denominator, so that's what I'm going to multiply by. Don't forget to multiply the 6 by x minus 1 as well, the negative 6. So all three positions. Okay, so with that in mind, all of the denominators should cancel out because this x minus 1 in the numerator cancels out that denominator. Alright, this x minus 1 cancels out this x minus 1. So when I recopy, I've got the 3, okay, and then I've got the minus 6. Now this x plus 1, x minus 1 is still there. And that's going to be equal to 5x. Alright, so no more fraction. Before we forget, we should go ahead and write down the restrictions though. Even though these canceled out, we still get a restriction that x cannot equal 1. That's our restriction. Alright, so going on with the problem, we have to distribute this negative 6. So that's going to give us negative 6x plus 6. So bringing down the 3 equals 5x. We have some like terms here. We have 3 and 6. So that's going to give us negative 6x plus 9 is equal to 5x. Now you see we have x on both sides of the equation. We need to get those together, so I'm going to add 6x to both sides. So that's going to give me 9 is equal to 11x. And then we would divide both sides by 11. So that gives us the final answer of x equals 9 over 11, 9/11ths. And that was not our excluded value, so we are good to go. Alright, let's take a look at number 3. We should factor this before we really get started. So we will have 5x over x minus 1, and then we have minus 2 equals. Now this will factor, so I'm going to have x plus 1 times x minus 1. So let's go ahead and mention the restrictions now. Based on this, x cannot equal 1. Based on this factor, x cannot equal negative 1. And this would give us x cannot equal 1 again. Okay? Now, we need to multiply by the factors that are in the denominator. So looking right here, I have x plus 1 and x minus 1. So that is what I need to multiply by. So I need to multiply every term by x plus 1, x minus 1. Okay, and what's going to happen is the x minus 1 will cancel out this x minus 1. Nothing cancels out here. Now over here, the x plus 1 and the x minus 1 both cancel out. So far that gives us 5x times x plus 1. And then here I have negative 2 times x plus 1, x minus 1. And that's going to be equal to 14. No more fractions. So this is going to give us, because we'll do the distributive property, so that'll be 5x squared plus 5x. Now, for this, remember that x plus 1, x minus 1 came from x minus 1 squared. So it will actually be easier to think of this as x, I didn't mean x minus 1 squared, x squared minus 1. So it's easier to think of it this way, x squared minus 1. So if I do the distributive property on this, then I will have negative 2x squared plus 2, okay, that's just quicker, is equal to 14. Okay, combining like terms, 5x squared minus 2x squared, that'll be 3x squared plus 5x plus 2 is equal to 14. Then we would subtract 14 from both sides. So that'll give me 3x squared plus 5x minus 12 is equal to 0. Okay, so let's see if we can factor this. 3x squared is going to factor only as 3x and x. Now 12 can either be 3 times 4 or 2 times 6 or 1 times 12. I'll try the 3 and the 4 first, but I won't put the 3 here because that would make a common factor, and that's not going to happen. All right, if there's no common factor in the previous step, there won't be a common factor now. So I'll go straight to trying 4 times 3 like this. Now remember, the inner plus the outer has to equal the middle. So right now, inner I have 4x, outer I have 9x. Is there a way that I can get a positive 5x out of that? Yes. If I have a negative 4 and a positive 9, that'll make positive 5. So here's my negative 4, and a positive 3 would make the positive 9. Will that give us negative 12? Yes, a negative times a positive is a negative. So there, we factored it correctly. So we can just go ahead and set these factors equal to 0. So if I have 3x minus 4 equals 0 and x plus 3 equals 0, then I would add 4 to both sides, subtract 3 from both sides. So that's going to give me 3x equals 4, and this will give me x equals negative 3. So that's one of my solutions right there, as long as it's not an excluded value. And here I need to go ahead and divide by 3. Okay, so that's going to give me x equals 4/3. Okay, are any of these excluded values? Nope. So these are the solutions to number 3. Alright, problem number 4. Again, let's definitely factor first. So we're going to have 1 over x minus 5 plus 1 over x minus 5, and that's going to equal x plus 3 over x plus 5 x minus 5. So I'm going to look at the denominators. I see an x minus 5 and I see an x plus 5. So even though there are 3 x minus 5s, I'm not going to multiply by x minus 5 3 times. Okay, I'm just going to multiply each term by x plus 5, x minus 5. So x plus 5, x minus 5. X plus 5, x minus 5. And x plus 5, x minus 5. Okay, if I do that, I will cancel out all denominators, and that's my goal right now. So these x minus 5s will cancel out. These x minus 5s will also cancel out. The x plus 5, x minus 5 will cancel out. So that will leave me with the following. I've got x plus 5 right there. And then I've got another x plus 5 right here. Then over here I've got x plus 3. Okay, this looks pretty simple. So this is going to make 2x plus 10 is equal to x plus 3. Now I see I have x's on both sides, so I need to get them on the same side by subtracting x from both sides. So that's going to give me x plus 10 is equal to 3. Then I will subtract 10 from both sides. So that gives me x equals negative 7. Okay, so unless that is a restricted value, that should be my answer. But looking back to the beginning, the restricted values are x cannot equal 5 because of these. X cannot equal negative 5 because of these. Alright, those are the restrictions. So that's the answer for number 4. Okay, that's a good place to go ahead and end this video. And we still have 4 more problems to do, but I'm going to put these other problems on the next video.